Hey guys, we're going to be starting on 2.5, which is proving statements about segments. This is day 1. This will be a 2-day notes video. So our goal for today is we are going to justify statements about congruent segments. Now remember, congruent segments are represented with this symbol. So anytime you see that symbol, you know that they are congruent. So let's review some terms that we've talked about. And the first term that we see is called a theorem. Now remember, a theorem must be proven. It must be proven. So it's a true statement that follows as a result of other true statements, meaning it must be proven. That's different from a postulate. If we talk about a postulate does not need to be proven. It is just a rule. Now, we prove theorems using the format in a 2-column proof. So remember, our 2-column proofs look like this, where it's 2 columns. The left side is labeled statements, and the right side is labeled your reasons. They are numbered statements and reasons that show the logical order of an argument. We always number them, and our first number is going to be listed as given. Now, I'm going to tell you, you can have multiple givens. So you can have 1 or maybe even 2 reasons that are going to be given. Whatever the problem says is given, that's what you're going to list as given. So if they give you 2 items that are given, then you're going to write 2 statements that they give you and list the reason as given. And then you're going to move into step 3, 4, or so on in order to logically prove whatever the statements are. And then we have congruent segments, where your segments are equal. Now, we're going to talk about this as the definition of congruent segments. And that's how we'll list it under reasons in any proof that we write. So a quick review of our properties, 3 specifically, is going to be the symmetric property of equality, where we have if AB equals CD, then the length CD equals AB. So basically, if we have a line segment AB, and we have another line segment, CD. And we say that the line segment AB is 4, and AB equals CD. Well, if we know that AB equals CD, then we can assume that the line segment CD is also 4. Well, if the line segment CD is 4, then we can also assume that the line segment AB is 4. This is symmetry. So that is the symmetric property because you are flipping it. So if AB is congruent to CD, then CD must be congruent to AB. Now, if we look at a reflexive property, remember, reflexive is like you're looking in a mirror. So if I have AB here, a line segment, and the length of my line segment is 6 for AB, well then guess what? That means that another line segment AB would be 6. So it's reflective. So like when you look in a mirror, what looks back? Well, you do. So it reflects, so it's the same. The transitive property of equality is saying that if AB equals CD and CD equals EF, then AB must be EF. So if the length of AB and CD are 4, and the length of CD and EF are 4, then AB must be 4. Okay, so basically if we have a line segment AB, and we have another line segment CD, and we have a third line segment EF. Well, if I tell you that AB equals CD, and I tell you that AB is 10, well, if AB equals CD, then CD must be 10. Right? Now, if CD equals EF, then EF must be 10. Then AB should equal EF. Well, it does, because they all equal one another. That's the transitive property of equality. And we're going to use these three properties in order to talk about congruence, because we're specifically talking about congruent segments. So let's go ahead and look here. It's the properties of segment congruence. Now, this is a theorem. This is a 2.1 theorem here. So just saying we're in chapter 2. And basically what we need to show is that we need to prove all three of these properties. So we have three of them here. We have the reflexive property, the symmetric property, and the transitive property. And because it's a theorem, it must be proven. So all of our theorems must be proven. And so we're going to go about proving the first one. So let's look at, we'll actually look at the symmetric property first. So if we look at the symmetric property here, it says that if AB is congruent to CD, then the line segment CD must be congruent to the line segment AB. Now I want to be a quick refresher from the very beginning, from chapter 1, that this represents a line segment AB. And this, AB without the line above it, represents the length. Okay, so we have to make sure we're talking about the same thing. So this would be with congruency, and this would be using an equal sign. So if we said that AB, the line segment AB, equals the line segment CD, you can't do that. You have to make sure it has a congruent sign. Now if we're just talking about length, AB is equal to CD. Now this means the same thing, except for in this case you're talking about a line segment, and in this case you're talking about a length. Okay? So make sure you understand the difference when you use the congruent symbol versus when you use the equal sign. So let's go ahead and look at the symmetric property of congruence first, and we'll go back to that. So let's look at this one. For example 1, we are going to prove the symmetric property of segment congruence as follows. Okay, so what they give us two lines in the figure to the right, and they tell us that PQ, the line segment PQ, is congruent to the line segment XY. Okay, that's what they tell us. They want us to prove that XY is congruent to the line segment PQ. So how are we going to go about doing that? We're going to use a couple of things. We're going to use the definition of congruence, and we're going to use the symmetric properties, and we'll be able to prove why both of these line segments are congruent to one another. So anytime we're writing a proof, we need to write our first reason is what is given. So I'm going to write given as my first reason. And they tell us that line segment PQ is congruent with line segment XY. So I'm going to write that under statements. Just like that. And they want us to prove, so I'm going to check that off, perfect. They want us to prove that XY is congruent to PQ, okay? Well, I know that's going to be my last statement. Now listen, I will always give you the number of statements, so you can go ahead and write our very last statement here at the bottom. And we filled in most of our proof. Not most of it, but a lot. And because PQ and XY are congruent with one another, you can represent that using this dash. So if you put a little dash, that means that those two are the exact same length. Now remember, if we talk about length, it would be written as PQ equals XY instead of the congruent symbol when we're talking about the actual line segment. Okay, so let's go ahead and look at what our next statement would be. Well, we could actually look at this, and I kind of gave you the answer up here a little prematurely, but if they are congruent, if the line segments are congruent, then we automatically know that the lengths are equal. So that's going to be our next statement. The line segments are congruent, then the lengths are equal. Now, what is that reason? What shows that how we can move from here to here? Well, what shows that is going to be the definition of congruent segments. So then our reason is the definition of congruent segments. Well, if they want us to use the symmetric property here to show segment congruence, so if we look at this and we use the symmetric property, what would our statement look like? Well, our statement is going to look like where it's flipped. So if PQ equals XY, then what do we know from the symmetric property? Well, we know that XY equals PQ. So that's going to use our symmetric property of congruence. Of equality. The symmetric property of equality. And now from here to here, how do we move from where the lengths are equal, but now the line segments are congruent? Well, if we know that the lengths are equal, we're working backwards here from the line segments are congruent, then your reason is the definition of congruent segments. And that is proving that two segments are congruent using the symmetric property. So now let's look back here. We're going to go back and we're now going to look at the first one. We're going to look at reflexive property. We're going to prove that segment congruence using the reflexive property. So let's go ahead and go here. So it says that EF is a line segment. Okay, so they give us the line segment, and then they said that line segment EF is congruent to the line segment EF. Okay, so that is going to be using the reflexive property, but now we have to actually prove it. Okay, so our first reason is always going to be what is given. So what we're going to write here is just EF is a line segment. And we want to prove that EF, the line segment EF, is congruent to the line segment EF. So if we know that the line segment is a line segment, right, EF, using the reflexive property. So I want to use the reflexive property, so we know that EF is equal to EF using the reflexive property. And then to move from EF equals EF, then the line segment EF is congruent to the line segment EF. We're going to see that moving from reflexive property reason, we can say that we are using the definition of congruence in order to show that the line segments are congruent. All right, so now we're going to look at the third one using the transitive property here. So let's go ahead and prove the transitive property of segment congruence. So they give us 3 line segments. They tell us that AB is congruent, so AB is congruent to JK, and we can represent that using a dash. And then JK is congruent to ST, so we can represent that using a dash. They want us to prove that AB and ST are also congruent using the transitive property, okay? So our first reason here is going to be what is given. So the first thing that they give us is going to be the line segment AB is congruent to the line segment JK. The second thing that they give us is that the line segment JK is congruent to the line segment ST. Okay, so they give us that information, and that's really all we need to know in order to figure out why AB is congruent with ST. So our first step is going to be rewriting this in lengths, in terms of lengths. So if we rewrite this in terms of, I messed up, there we go. In terms of lengths, we can rewrite it as the length of AB equals the length of JK, and the length of JK equals the length of ST. Now we use that as our reason of definition of congruent segments. And because AB equals JK and JK equals ST, we know through the transitive property, if you were to finish that statement, which we have been doing, then AB must equal ST. And if AB equals ST, then the line segment AB must be congruent with the line segment ST. And that's also going to be using our definition of congruent segments. Okay, so we've just proven the properties of equality, the reflexive property, the symmetric property, and the transitive property works also for the properties of congruence. So we've used the properties of equality in order to prove these properties of segment congruence. Okay, so your homework for tonight is going to be practice worksheet A, and it's going to be numbers 1 through 11. So if you look at this, on numbers 1 through 3, you're just going to match the correct property with each property of congruence, okay? So you're going to use what we just saw to match those properties. And then you're going to do 4 through 9, which is marking the diagram with the given information. So remember, if I told you that line segment AB and line segment CD are congruent with one another, then how would I represent that? Well, I would represent that with a dash. So I would put a dash here on AB and I would put a dash here on CD. Now, what if I told you that I gave you 2 more lines and I tell you EF, let me make it a little longer, line segment EF, if I can get it right, and line segment HI. So if I say EF is congruent with HI, but it's all in the same problem, then I'm going to also write a dash, but in this case I'm going to write 2 lines, because now I know that those 2 are equal to one another, and now I know that those 2 are also equal to one another, but they don't necessarily equal each other, okay? So that's exactly what they want you to do on 4 through 9. Where 4, you're going to say, okay, AB is congruent with AC. Well, if they're congruent, well, how would we represent that? Well, we're going to represent that with a dash mark. And you're going to do that for the rest of the 5. And then you're going to look at 10 and 11. So 10 and 11 give you an argument. They tell you what they're trying to prove, and they want you to write the reasons to the side. So they give you the order, they just want you to write the reasons for number 10, and then we'll look at number 11, same thing. Okay, so go ahead, make sure you use your notes for your properties, in order to complete 10 and 11. But you're going to complete it either on a separate piece of paper or you can print this out and complete it on that. Okay, but that concludes our first day of 2.5 practice.